Okay, so Unit 3, Lesson 4 involves solving equivalent rational expressions. What does that mean? To translate it into terms you like, equivalent means equal, and rational expressions mean fractions. So we are going to be solving equations that contain fractions, much like example 1 here. So notice we have fractions that are being commanded to be combined by subtraction. Usually we must find a common denominator. Well, I'm going to show you 2 ways to solve fractional equations. There is no one way to do it. Sometimes I'll cross multiply, and sometimes I'll use this get rid of the denominator. It all depends on which version looks easier based on the problem. So I'm going to show you both. So the first one here says method of combine, then cross multiply. So I have an x over 5 minus an x over 10. So that's the only part I'm going to concentrate on right now. I'm not going to write the equals 7. So I have to find a common denominator, which means I'm going to multiply this by 2, multiply this by 2, and I get 2x over 10 minus x over 10. Now my brain tells me I may put these 2 fractions together to form 1 because of a common denominator. X over 10. And now I can finally bring in the equals 7. Cross multiply. When I have a fraction equaling a fraction, hopefully you learned in 6th grade, you may cross multiply. And you get 70 equals x. So now I'm going to show you another way. I'm going to show you a way that we get rid of the denominator so we don't even have to worry about it. So x over 5 minus x over 10 equals 7. So my method here is find the least common denominator, then multiply every term by it. Okay, so in this case, when I look, the common denominator we found was 10. So this term is going to get multiplied by 10. This second term is going to get multiplied by 10. And then this 7 is going to get multiplied by 10. So if I were to rewrite this, I have 10 times x over 5 minus 10 times x over 10 equals 10 times 7. And what happens is we can cancel. That's why that unit on canceling fractions was so important. No canceling going on here. Hey, look what we get. The same answer. All right, so now we have a little bit more of a complex one. And again, I'll show you both ways. And you can define, and you can determine, we'll move that out, which one you would like to do. All right, so method of combining and then cross multiplying. Well, right here, we have to combine, which means we have to make soup. If I look at this common denominator of the last one, this is 3b minus 2 and 3b plus 2. So in order to combine, everybody has to have that common denominator. Well, that means you need a 3b plus 2, and you need a 3b minus 2. And what I do to the denominator, I have to do to the numerator. All right, so I like seeing these in parentheses. this would become 12b plus 8 over 3b plus 2, 3b minus 2, minus, this would become 21b minus 14 over 3b plus 2, 3b minus 2. All right, I'm going to just combine this right now, and I have to be aware, I've been showing you this, I think it's like the fourth one in a row. When you subtract, you must add the opposite. So 12b plus negative 21b gets me negative 9b. 8 plus 14 gets me 22, all over 3b plus 2, 3b minus 2 equals 1 over 9b squared minus 4. Now this is a case where cross multiplying is going to leave us with a really ugliness. I don't want to multiply this to that. I'm going to end up with cubes and all sorts of nastiness. But what you do want to realize is that you already have the denominators equal to each other. See, you're trying to get fraction number 1 over here equal to fraction number 2. Well, you're halfway there. You have the denominators equal. So what we can choose to do right now is ignore the denominators because they're equal. And you're left with 9b plus 22 equals 1. Solve it up. Negative 9b equals negative 21. Divide by negative 9. B equals 7 over 3. Now I'm going to do that same problem over here, but I'm going to be doing it by multiplying through by the common denominator. So by now, I've realized that when I factored this out, I got 3b plus 2, 3b minus 2. That was my common denominator. So everybody gets multiplied by a 3b minus 2 and a 3b plus 2. That was the common denominator. And I like to see them in parentheses. And now I can cancel. Okay, you and you cancel out, leaving me with 4 times b is 12b plus 8. Hey! Over here, 3b plus 2 cancels out with a 3b plus 2, leaving me with, 21b minus 14, but I'm going to put that in parentheses because I've got this minus over here. And then over here, this and this cancel out because that's really 9b squared minus 4 equals 1. So let's see, 12b plus 8 minus 21b, negative times negative makes that 14b equals 1. 12b minus 21b is negative 9b. 8 plus 14, hey, shocking, isn't it? I get the same answer. Now, what's this thing down here? Carefully look at your answer. Is 7 over 3 a viable answer? In other words, we always have to check. So if I put 7 over 3 in for B, would I ever get a 0? Nope, I get a 5 here. Nope, I get a 9 here. So it's good. So this is a good answer. It's not an extraneous root, extra root as we would call it. And once again, use your friend mathway.com. You can always enter the problem there and check it. We're going to come back to Mathway in a minute. Right here. Let's do both ways and see what happens. All right. Method of combining, then cross multiply. Well, first thing I'm going to do is instead of combining, I'm going to realize that if I move this fraction right over to the right side, I don't have to worry about combining. I can just cross multiply and solve. Wait. -3 equals 0. That's, where are my x's? Where are my a's? Where's my answer? All right, leave that there. Let's try this by getting rid of a denominator. Maybe I did something wrong. All right, so I'm going to factor this. All right, so my common denominator looks to be, well, this has a 3 and this has a 3. So my common denominator looks to be 3 times a minus 1. All right, so you're going to get multiplied by that, you're going to get multiplied by that, and you're going to get multiplied by that. Let's cancel out. Okay, a 3a minus 1, well, you're a 3 and an a minus 1, so that leaves me with just the a there. The 3a and the 3a cancel, so I'm left with, let's see, a minus 1 here minus a equals 0. A minus a cancel out. -1 equals 0. Over here I got -3 equals 0. What's going on? I'm going to go back to that math way like I told you. I'm going to enter this problem. Okay, parentheses. First problem was, oops, I didn't put my parentheses in there, but that's okay. 1 over 3a. 1 over 3a minus, okay, and in parentheses here we're going to have another fraction, and that was the fraction 1 over 3a minus 3. 1 over 3a minus 3 equals 0. Okay, solve for a. That's what I want to do. Come on, give me an answer. There are no values of a that make this equation true. There's no solution. And yeah, we got to trust ourselves down here. Both of these were a false statement. So when a false statement occurs, we have to remember there is no solution. And some of you might have gotten that from up here just looking at it. How can 1 divided by 3a minus a number that's not quite it? It's 1 over 3a minus 3, so this number's smaller than that. Leave me with 0. It's impossible.